All right, this is lesson 6.2. In this lesson, we'll be figuring out how to prove that triangles are similar by using the similarity theorem angle-angle. Okay, and we'll be looking at the angles of a triangle and determining if those triangles are similar. So the angle-angle similarity theorem says that if two angles of one triangle are congruent to two angles of another triangle, then those two triangles are similar. So far in this unit, we've been focused on determining if polygons are similar. And so we've been looking at all of their angles and all of their sides. But what we see here is that with triangles specifically, this theorem tells us that we can just look at two angles in each of the triangles. If we can show that two angles in one triangle are congruent to two angles in another triangle, then we know that those two triangles are similar to each other, and we don't have to look at the other angle or the rest of the sides. So that's what the angle-angle similarity theorem is saying. You'll also notice that in this lesson we want to pay attention to what's called the similarity statement. Like what you're seeing here, this says triangle ABC is similar to, this is the symbol for similar, triangle DEF. That was these figures here. This is what's called a similarity statement, and it is written in such a way that it is telling you which angles are congruent to each other and which sides are corresponding to each other. And so what we see here with A, B, C, and D, E, F is angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. Right? So when you read a similarity statement or when you write a similarity statement, it should be in that way, that the corresponding angles, the congruent angles for similar triangles should match up. So A and D, B and E, C and F. So we need to make sure we understand how to write that similarity statement. So how do we use the angle-angle similarity theorem? So if you're given two triangles and you want to figure out are they similar or not, if you know two of the angles, then you can determine if those triangles are similar. So as you see in this figure here, we're given these two triangles, and we want to determine if they're similar. So we're told that D is a right angle, so that's 90 degrees, and G is also a right angle, so it's 90 degrees. So we know that D and G are congruent to each other because they're both right angles. And then we can see in the figure that this angle C is 26 degrees and this angle H is 64 degrees. And those obviously aren't congruent. But let's look at the third angle and see what that can tell us. So if we look at angle E in this smaller triangle, we can figure out what angle E is because we know that all the angles in a triangle should add up to 180 degrees. So the 26 plus the 90 plus the angle E should equal 180 degrees. So if I take 180 minus 90 minus 26, that gives me 64. So angle E, we find, is 64 degrees. And so that is congruent to angle H, which is also 64 degrees. So angles E and H are congruent to each other. And now that we've shown that D and G are congruent to each other and E and H are congruent to each other, by the angle-angle similarity theorem, we can say that triangle CDE and KGH are similar to each other. So we did have to figure out what one of those unknown angles what it was in order to determine that E and H were congruent to each other. But once we did, we had two pairs of angles that were congruent, and so we could say by the angle-angle similarity theorem that these two triangles were similar, and we didn't have to look at anything else. All right, so let's look at one example where we're again using the angle-angle similarity theorem to show that triangles are similar, and then another example where we're using that theorem and other similarity knowledge in order to find the length of an object. So this is number 5 in your notes in our second section. It says determine whether the triangles are similar, and if they are, write a similarity statement and explain your reasoning. And we do want to be able to explain our reasoning. How do we know that these two triangles are actually similar? So let's first look at see what the figure is giving us. So in this triangle, we have kind of a triangle on top of another triangle, right? It's this larger triangle, ADC, and then this smaller triangle with inside of it, AEB. And we're told that angle B here, ABE, and angle C, or ACD, are both 52 degrees. So we know that those angles are congruent to each other. So if we can find one other angle that both of those triangles have that are congruent to each other, then we could show them to be similar. So all we know at first is that angle ABE, this angle here, is congruent to angle ACD, this angle here, because they're both 52 degrees. So are there any other angles that we can understand something about? Well, E and D here we don't know. Okay? We don't know what those are. And we don't know what A is either. And so I can't take 180 minus 52 and then minus something else to figure out what the others are. So I can't do something like that. But what I do notice is that, because all triangles have to have those three angles, is triangle ADC has triangle A, D, and C, or angles A, D, and C. Triangle AEB has angles A, E, and B. And if you notice, they both have angle A. A is the angle for both the larger triangle and the smaller triangle. And it's the same angle, right? Because it's angle A in both cases. And so what we can say is that angle A is congruent to angle A, right? This angle is congruent to itself. And if you remember from our second unit, we talked about this. This is because of the reflexive property of congruence, because A is congruent to itself, right? That's what the reflexive property of congruence is saying. So now we've shown that these two angles are congruent to each other, and A, which is an angle in both the small and the larger triangle, is congruent to itself. So now, by the angle-angle similarity theorem, which just means that we found that two angles are congruent to each other in both triangles, I'm using THM to abbreviate theorem. By the angle-angle similarity theorem, triangle ACD is similar to triangle ABE. So this larger triangle is similar to this smaller triangle here. And that's because these angles are congruent and A is congruent to itself. And this is my similarity statement, right? When it says write a similarity statement, that's what it is. And when it said explain your reasoning, I talked about the reflexive property, and I said that I used the angle-angle similarity theorem to show this to be true. Okay? And so this is how you would approach a problem like this. How do I show these triangles to be similar to each other? All right, let's look at number 8 on that same page in your notes, and we're going to use this picture in our knowledge of similarity in order to figure out something about it. So we're told that a flagpole casts a shadow that's 50 feet long, and at the same time a woman standing nearby who is 5 feet 4 inches casts a shadow that is 40 inches long. How tall is the flagpole to the nearest foot? Okay, so how are we going to figure this out? Well, let's zoom in a little bit to our picture and see if we can label things to work it out more. So what are we told? We're told that this shadow from the flagpole is 50 feet. And we're told that this woman is 5 feet 4 inches, or 60 inches. And she's casting a shadow that's 40 inches long. And we want to figure out what's the length of this flagpole. So what are we going to do? How are we going to figure this out? Well, if you notice, these are pretty much just triangles, right? The woman and her shadow, and the flagpole and its shadow, these are just triangles. But what's that third side? Okay? What's that third side? Well, what's creating the shadow? It's the sun. Okay? The sun is creating that shadow. And so that's the third side, is the sun rays, okay, coming down over this woman and this flagpole. And so that's what completes our triangle here. Okay? So now we have two triangles, and we want to figure out what's the length of one of those sides of the triangles. Well, this is where we can use our knowledge of similarity. If we can show that these two triangles are similar, then we can show that there's a relationship or a proportion between their sides. So how do we first show that these triangles are similar to each other? Well, we can look at their angles. The woman is going to form a right angle with the ground, and so is the flagpole. Okay? They're both standing up perfectly straight, okay? in this scenario. And so they're both forming right angles with the ground. And so in that case, there's one angle that they both have that are in common, that are congruent to each other. Okay? Do they have any other angles that are congruent to each other? Well, we don't know anything about these angles here, but we do know that the sun is going to come down at the same angle over both of them. Okay, so this angle here and this angle here are going to be congruent to each other as well, because the sun is going to come down at that same angle in both cases. They're standing right next to each other. It's going to come down over at the same, the sun is unobstructed, so it's coming down over the same angle. So now that I've shown that both of these triangles have two pairs of angles that are congruent to each other, and so those angles, or these triangles, are similar to each other. By the angle-angle similarity theorem, these triangles are going to be similar to each other. Now that I've shown that they're similar to each other, I can start setting up a proportion, because I now know there's a relationship between their sides. Okay, so let's set up a proportion and then we'll talk about it. Okay, so this is a proportion I can set up for these two triangles because we know they're similar, so we know there's a proportion between their sides. And so how did I set this up? Well, I'm looking for x here, right? X is the length of the flagpole, and 64, that's related to the side, the height of the woman. And so it's 64 inches. I said 60 down here. Hopefully you caught my mistake. This should be 64, okay, down here. Hopefully you caught that mistake. But that's the ratio between the height of the flagpole and the height of the woman. X feet and 64 inches. And I converted that to inches because over here I'm going to do feet over inches, right? Because they gave us her shadow in inches as well. So as long as I'm consistent with my units, feet over inches, that's okay. You could convert it all to the same measurement, and you could that's fine. Or you can do it like this. And over here I did the shadow 50 feet over the woman's shadow 40 inches and compared those sides, found that ratio. Remember, the ratio between all of the sides should be the same. That's what makes them proportional. So I set up this proportion, and now I'm going to solve it by cross-multiplying. All right, so after I solve that proportion, I get x is equal to 80, okay, and x was in feet. X was in feet, so that's what my final answer is in. So this flagpole is 80 feet tall. Okay? And I figured that out because I had similar triangles here, and I had proportional sides. And so after setting up this proportion, I found that x is equal to 80, and so that is the height of the flagpole. So that's how I can use the angle-angle similarity theorem to show that the triangle is similar, and then use my knowledge about similarity and proportional sides to solve for x.